SQL 50, Part 2. In my last video, I said we went over the first 5 questions of SQL 50. That being 1, 2, 3, 4, 5. However, I did make a mistake. We went from 1 to 4 and not 1 to 5. So today, we'll start with the 5th question called invalid tweets. The first thing I will do is go back to my code and I will reset it to default. Alright, let's look at our table. So the question is called the question number is 1683, invalid tweets. We have a table called tweets with 2 attributes also called columns. We have a tweet ID, which is of type integer, and a content attribute, which is of type variable char, which is just a string of length 0 all the way to some upper bound. We're also given that tweet ID is the primary key for this table. This table contains all the tweets in a social media app. I wonder what. We are tasked to write a solution to find the IDs of the invalid tweets. The tweet is invalid if the number of characters used in the content of the tweet is strictly greater than 15. And we can return the result table in any order. Now remember, when we do a select statement, what we get back is a table. This states that we can return the table in any order. Okay, here's our input table, which is tweets. We have tweet ID 1, which is vote for Biden, and then tweet ID 2, let us make America great again. A little political here, but I don't really care. I'm not American. So, what do we have to do? So we know we have to select the tweet ID from the table called tweets. And if we just do this, we get a wrong answer and we get back tweet ID 1 and 2. Because the question requires us to filter this table into a format such that the length, let me say that again. We have our output table, which is just tweet ID 1 and 2. And it's incorrect. Why? Because we only want to consider tweet ID where the content of the tweet, which is this attribute, is greater than 15. So we know that content is a variable char. So if we do this, we say where, so we can do a filter where content is greater than 15. Let us try running that. And we get a wrong answer. In fact, we get nothing, because this doesn't actually do the check that we expect it to. This statement here, or this query, nope, this operation does not check if the length of characters is greater than 15. This is actually checking the value of content, but we need to check the length of the value. And we do that by applying the following function, char length. And because it's a function, we will wrap its parameters in parentheses. And now when we run this, char length does not exist because I spelled it wrong. Len, I believe, GTH. Yeah. So there we go, a very simple question, very straightforward answer. If, unlike me, you know how to spell, you won't get a, what's an opposite of an accept? A reject. You will not get a rejection. And there we go. Once we submit it, we get back our successful attempt. Next question. Reset default. First off, we notice we have 2 tables. Oh no, 2 tables. The question is 1378. Replace employee ID with the unique identifier. So we have a table called employees. It has two attributes, an integer of type, an ID of type integer, a name of type variable char. We are given that ID is a primary key for this table. Each row of this table contains the ID and the name of an employee in a company. We next have employee UNI, which is the ID and unique ID attributes for the table, both of type integer. And we are given that ID and unique ID is the combination of columns that is the primary key for this table. Each row of this table contains the ID and the corresponding unique ID of an employee in the company. Okay. We need to write a solution to show the unique ID of each user. If a user does not have a unique ID, replace and just show null. We can return the result table in any order. Now let's read this. Write a solution to show the unique ID of each user. But we have a table called employee UNI, so why don't we just do this? Select unique ID from employee UNI, because that's the unique ID, right? Unique ID. But it's wrong. We get back 1, 2, 3. What's required is 2, 3, 1, but also including Alice and Bob. Let's go down here. We have our input tables. We have the employees table, this one here. We notice we have ID and name, 1 Alice, 7 Bob, 11 Mare, 90 Winston, 3 Jonathan. We then have employee UNI table. ID of 3, a unique ID of 1. ID of 11, unique ID of 2. ID of 90, unique ID of 3. So we need to select from the employee UNI table the unique ID, and we also need to select the name. However, if we notice the employee UNI table does not have a name attribute. When we are dealing with more than one table and we need to access data from more than one table, we need to join tables or in some way access their data using a join. And we can do it in the following way. We can say select employee UNI dot unique ID from employee UNI. Now, this statement, well, this query, and the one I wrote a few moments ago are practically the same, except right now I'm using the dot access operator right here. This and this are the same thing. So what's different? Well, I also need to access the employees table and grab the name. But I'm saying from employee UNI. But I also just said that employee UNI does not have a name attribute. So what can I do? I say right join employees. This says also consider the employees table, but only consider it on the fact that employee UNI dot ID is equal to employees dot ID. So only give me back the rows where the employee UNI ID is equal to the employee's ID. In this case, notice we will have, let's see, employees UNI. Did I spell that right? Employee UNI. So it'll be 3, 11, and 90 from this table, which will match to 3, 11, and 90 from the employees table. Now, because we do a right join, it will also return where there's no match, which means you'll also get Alice and Bob. Now, once we run this, There we go. We have an accepted case. And we submit, Control Enter, or just use the user interface and click the submit button. And there we go, a successful submission. Oh, they did a left join, I did a right join. Notice this is the exact same thing we did, but in this case they chose to use the left table as employee, where I used the right table. Let's go to the next question. Product sales analysis 1. Reset it to default. So I have a table called sales, and I have 5 columns, all of type integer. I am told that sale ID and year is a primary key for this table. So a combination of columns is a unique value for this table. I am also told that product ID is a foreign key to product table. Okay. Each row of this table shows a sale on the product ID in a certain year. Note that the price is per unit. You know that what a primary key does, it uniquely identifies values in a table. A foreign key establishes a relationship between tables or a table itself. Here is a table called product. Product ID is the primary key of this table. Each row of this table indicates the product name of each product. Write a solution to report the product name, year, and price for each sales ID in the sales table. And we can return the resulting table in any order. And here's an example. So we need the product name, which is from the product table, the year, which is from the sales table, the price, which is also from the sales table, and the sale ID, which is also in the sales table. Notice we are required to grab data from 2 tables, so we are in some way going to have to join them. Let's look at the columns that we have. Sales ID 127, no match in product table. Product ID 100, 100, 200. Any match in the product table? Yes, it also has a product ID column. So therefore, this is most likely going to be our joining column. So let's try to tackle the question. Let's select product name and year and price from product. Join sales on product.product ID equal to sales.product ID. That's going to be wrong. Even though I spelled it wrong, it came out right. I thought it wouldn't. Anyway, there we go. We get back the correct answer. Output and expected. Because what it did was this. It went and looked at the product table, and then it looked at the sales table. And it did not return all the values. It only returned the product name, year, and price, but only where the product ID was equal to the sales.product ID. And if we submit this, we get back an accepted submission. Let's go back and let's tackle another question. Okay, let's get rid of this. Customer who visited but did not make any transactions. We are given the 2 tables. Table 1 is called visits. 2 attributes, visitor ID and customer ID, both of type integer. Visitor ID is a column with unique values for this table. Whether or not it is the primary key, we cannot assume. All we know is that visitor ID is unique. The table contains information about the customers who visited the mall. Next, we have transactions table. This has 3 attributes, also all type integer. Transaction ID is a column with unique values for this table. This table contains information about the transactions made during the visit ID. We have to write a solution to find the ID of users, but only the users who visited without making any transactions. And we also need the number of times they made a visit without making a transaction. We can return a table in any order. Here's the two tables data. Visitor, let's look at the output. 54. Let's look at customer 54. Slight interruption, but I am back. All right, so what was I saying? Oh yeah, let's look at the actual data. Let's look at the outputs table. We have a customer ID 54 and the number of transactions too. So let's look at it. Let's look at the visits table and find the customer 54. Here we go, 54 twice, and the visit ID is 7 and 8. However, these customers do not appear in the transactions table. Notice visit ID 7 and 8 is not here. So we'll count them as 1 and 2. Next we have 30 and 96. Here's 30 with visit ID of 4. Again, there is no visit ID of 4 here. Next we have customer ID of 96. If we look at 96, that associated visit ID is 6. Again, in the transactions table, there is no 6. These are the type of people we want. People who, yes, they are visitors, but they do not appear in the transactions table. There's a few ways we can do this. We can say select customer ID, and we can do, if you are familiar with functions, we can do a count of the customer ID, and we can pass in an alias by as, or if you don't want to, that's also fine, but I prefer using as count, and I'm getting this name from here, count number transactions, as count number of transactions from visits. Here, this table. But I only want it where visit ID not in. Now we'll do a subquery, select visit ID from transactions. And we'll also do a group by customer ID, just so then we don't get, actually remove this for now. I'll see if I can show you why we don't want this. It's often difficult to go back to SQL queries and show you how it's built from scratch, because obviously when I'm doing it myself, I do it obviously much slower and I go through each individual section. Here's what we get. We get custom ID of 30 and a count of transactions of 4. And if we come down here, notice 30 is included, but we get 4, because what happened is we did get a successful count, but the count was summed up. So 2 plus 1 plus 1 is 4. We do not want that. We want to group by customer ID. If I run this, this will be successful. There we go. So it did the exact same thing. It again counted the number of transactions, but this time it did it for each customer because I did buy a group by customer ID. Let's go through this. So I say I want the attribute customer ID. I also want you to count the customer ID, and I pass in an alias from the visits table. But if that was the case, and if I didn't include this line 6 and 7, all I would get is this entire table and the number of times they appeared, which is not what I want. I only want it when the visit ID is not in the transactions table. I did not have to do a join. I did a subquery, because remember, this portion here returns a table. And what I said was, do not consider the visit ID where that visit ID is in the transactions table. That's what my subquery did. And I then grouped by customer ID. Still recording, that's great, okay. And if we do a submission, and there we go. Now let's go to the next question. So let me reset this to code default. Let me check on my dog is barking. It was a delivery, and my dog did not like that. But anyway, look, we're back to one table. And the table is called rising temperature. Well, I mean, the question is 197, rising temperature. The table is called weather. It has three attributes. Again, an attribute is a column, ID of type integer, record date of type date, and temperature of type integer. ID is a column with unique values. For this table, there are no different rows with the same record date. This table contains information about the temperature on a certain day. We have to write a solution to find all dates' IDs with higher temperatures compared to its previous date. So here's the thing. We know that we need a ID from the weather table, but the condition is only where, how can I say this? Temperature is higher than previous day temperature. That's what we need. We need to somehow take our query table and reduce it to only where the temperature was greater than the prior day's temperature. That's what we need. I'll comment that out. Let's look at our input data. We have the weather table, and our output is IDs 2 and 4. If I look at ID 2, I notice the temperature is 25, and if I look at the day prior, the temperature is 10. Yes, this is a successful condition, it's a successful match. Next is 4. If I look at ID 4, I have temperature of 30, and if I look at the prior day, I have temperature of 20. Again, a successful match. How do we do that? We can do this. We can say select w1, and just stay with me here, w1.id from weather as w1. Yes, you can also pass alias to your tables. And also, we can select multiple tables to pull data from. So I can also do this, weather as w2. And right now I have two tables. And if I run this, we get back, you notice we get back 1, 2, 3, 4, and 1, 2, 3, 4 again and again. In fact, we have it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that makes sense because what happens was we essentially did a Cartesian product. 4 by 4 is 16. That's not what we want though. We only want it where, and then we'll use another function here, date difference. And here's the thing, if you aren't familiar with SQL, you probably aren't aware that there are functions that you can take advantage of. Worst comes to worst, open a new tab and just type, look up here and see what code you're writing, in my case MySQL. Type in MySQL functions and you'll get a very nice website probably telling you all the functions that are available for use. w1.recordDate and w2.recordDate is equal to 1. What this function does is it takes two date attributes and it compares them. In this case, it minuses them. Date difference is i.e. date subtraction. We only want the difference where it's 1. And if I do that, I get wrong, I get back 2, 3, 4. And the reason I get back 2, 3, 4 is because before 4 there was 3, before 3 there was 2, before 2 there was 1, and obviously 1 doesn't have a day before it. But I need to filter it even more because I want to add an and say w1 dot temperature is greater than w2 dot temperature. And now when I run it, there we go. Submit it. And there we go. Let's go back to our description, and that's how we tackle that question. Again, for this one, if you aren't aware that SQL has functions, you may probably will get stuck here. But worst comes to worst, if you do get stuck, in that case, go and look at the solutions, and you'll become aware of what's happening. Don't spend too many time just working on a question. This is not here, but typically, sometimes you'll actually have helpful tabs down here that you can click on and it'll tell you what's going on, or at least give you a hint. Let's do the next question. Let's reduce this. I will get rid of this. I'll just get rid of all of it. Yeah, okay. Now, for this one, 1661, average time of process per machine. All right, so water break. Be back. 1661, average time of process per machine. Now, just because this question is easy does not mean it is easy. You will understand that once you start writing LeetCode, once you try solving LeetCode questions. The table is called activity, 4 attributes, machine ID and process ID of type integer, timestamp of type float, and activity type, which is an enumerable type, which means it can take on a value from a tuple. In this case, we can see that it can take on start and end. We also are given this description, quite lengthy. The table shows user activities for a factory website. Machine ID, process ID, activity type is a primary key, so a combination of columns for this table. Obviously, we're given what each column is. Timestamp is a float. This is important. Timestamp is a float representing the current time in seconds. Start means the machine starts the process at the given timestamp, and end means the machine ends the process at the given timestamp. The start timestamp will always be before the end timestamp, which makes sense. A process has to start before it ends, therefore start will always be before end. Right. We are also told there is a factory website that has several machines running the same number of processes. A process is a job in execution. Write a solution to find the average time each machine, again, write a solution to find the average time each machine takes to complete a process. We are also told here, if you aren't sure what average is, it is the time end minus the time start divided the average time is calculated by the total time to complete every process divided by the number of processes that were run. The resulting table should have the machine ID along with the average time, and we must pass it the alias processing time. And we also need to round it to 3 decimal places. Return the result table in any order. If we come down here, we notice we have machine ID 0 with 0.894 processing time. So let's look at activity table. We have machine ID 0 appearing 4 times. And machine with the ID of 0 has 2 processes. They both have their own ID, 0 and 1. And they both have a start and end ID. So this is the 4 rows we're focusing on now. I want you to grab a calculator and then do the end times minus the respective start times and then divide that by the number of processes. you will get back 0.894. And that is what we are trying to do. In fact, there's also an explanation down here. Let me see. Okay. 66% accept rate. Okay. So we know that we need a machine ID. Let me think how I'm going to go about doing this. Let's just, for now, let me just do this. Let me select timestamp dot end. That's not going to work. Let me think. Activity type, okay. I know what the solution is. I'm trying to teach it to you in a way that will make sense. I need to have table 1 and I need to have a table 2. I need table 1 to be all the start times. So start time, I'll just leave it as start because that's what it's called in the enumeration column. And I want table 2 to only be the end. And from that, I want to take end minus start to get the processing time. So because I'm thinking of 2 tables, I'm going to need to use in some way a join or just use the from clause and select 2 tables. So if I do a select a1 dot machine ID, and then if I do a2 dot timestamp, remember timestamp is just a float, minus a1 dot timestamp from activity vity as a1 join activity as a2. What I'm doing here is very straightforward. I want a1.machine ID and I pass the alias of the activity table as a1. I then want a2.timestamp minus a1.timestamp. But that's not going to work because timestamp, as we can see down here, is going to leave us with a bit of a problem. We need to clarify something. First off, we need to join